Hello. We get to solve more quadratic equations by completing the square. So let's look at the equation we're going to start with. 2x squared minus 12x equals 4. What do you notice is a little different about this than the ones we've been working on? I'll give you a hint. There is a 2 here. Usually we've been dealing with 1x squared, where the 1 we didn't even have to write because it was understood. Here there's a 2x squared. So let's get out the tiles and see what sense we can make of that. Okay, I'm not even adding the x's yet, but I can already tell that we've got a problem. Because if we've got one side that has a length of 2x and another side with a length of x, no matter what x's we add to the side, we're not going to have a square because the sides will not be equal. So I want to get this to x squared. I could divide it into two groups, get x squared and x squared. We could do it that way. So what does that look like algebraically? So let's think about this. We could do it by factoring out a 2. If we do that, then we're saying goodbye to the 2. Well, not yet, but almost goodbye to the 2. So let's factor it out. So we get 2 times x squared minus 6x. Y'all already know how to do that, so you're good there. And in order to say goodbye to that 2, I need to now divide it out. So I want to divide that side by 2. And we all know that you have to do the same thing to the other side. So divide that by 2. 2 divided by 2 gives us 1. So we've got left x squared minus 6x on the left. And 4 divided by 2 leaves us with 2 there. We haven't solved for x yet, but at least we've got it down to an x squared expression here that we can actually do something with. Now, before we complete the square, there's another way that we could do the same process that you might like better. It's kind of a matter of preference. So this time I want to go back to that original equation, 2x squared minus 12x equals 4. Same thing, I'm just going to do it slightly differently. So instead of factoring out the 2 and dividing by it, I'm just going to go straight to the division and divide each and every term by 2. So divide that by 2, divide that by 2, divide that by 2. And don't forget anything. So 2 divided by 2 leaves us with x squared. And then negative 12x divided by 2 leaves us with minus 6x. And 4 divided by 2 is 2. And looky there, we've got the same thing, which we should. Because all we were doing is getting it down to an x squared, so we can now complete the square. All right, so let's look at this. We got an x squared. Now we're in business. We've got 6 negative x's. And remember, we split those in half to have a chance of making a square. So we put 3 on one side and 3 negative x's on the other. So we split that negative 6 into 2 even sides there. It's not a perfect square, is it? Right. Equals, and it equals 2, so we need 2 units. Slide those on down. All right, so here to complete this square, to make it x minus 3, x minus 3, x minus 3 squared, something needs to go here. And we know that negative 3, I'm going to go ahead and write that in. Negative 3 times negative 3 gives us 9. So we need to add 9 tiles there. Now I could go ahead and fill those in. I'm not going to right now. I'm going to keep it with the number. And of course, if we add 9 to one side, we have to add 9 to the other. So if I'm writing this algebraically over here, I'm adding 9 and adding 9 to each side of the equal sign, one on one side and the other side. And let's look back at this. This dimension was an x minus 3, x minus 3. So we know that the whole reason that we added 9 here was to make this a perfect square. This is now a perfect square. And it's the perfect square that also goes by the name x minus 3 quantity squared, because the side lengths are x minus 3. And then 9 plus 2, 9, 10, 11, is 11. Now, from here on out, this is like what you've done before, where you take the square root of both sides and find the values for x. So go ahead and pause this video for a second and figure out what the values of x are, and then turn it back on and we'll see if you're correct. Did you get that x equals 3 plus or minus the square root of 11? Or maybe you got the decimal approximations of that. Maybe you got 6.32 and negative 0.32. So depending on how accurate you want to be, the answer with the square root is a great answer. This is an approximation because you had to round your decimals. Now this really, let's go ahead and check this in the calculator because we want to make sure that we are correct. Let's see if you can see that on here. There we go. Turning it on would be good. Oh, look, I already have those expressions in there. So I went back to the very original expression before I did anything to it and put the left-hand side in y1 and the right-hand side in y2. And if my answer is correct, 3 plus or minus the square root of 11, then in my table I should see y1 equal to y2 to mean that one side of the equation is equal to the other. Now currently my table doesn't have all these square roots in it. So remember, we can do second table set, and I'm just going to tell it to go straight to 3 plus the square root of 11. So 3 plus second square of 11. I'm going to hit second and then table so I can go back and look at my table. So this, they went ahead and the calculator doesn't leave it as a square root. It's actually giving you the decimal value of it. But notice that the left-hand side of the equation gives us 4, the right-hand side of the equation gives us 4. So that value is correct. And we would, of course, do the same thing with, let's do it with 3 minus the square root of 11. Go back to the table. So for that x value, the left-hand side and the right-hand side are equal. So our answers are correct. Yay! All right, so we have done a lot of work to get to this answer. Now, when we're doing this on the next problems, we're not going to do it both ways. Pick a way and go with it, all right? Three x squared minus 6x plus 3 equals 12. And here's another one where we've got something besides 1 in front of our x squared. So you can either factor it out and divide by it, or you can go ahead and divide everything by 3. That's what I'm going to do, but you're welcome to do either way. So divide this by 3, divide by 3, divide by 3, divide by 3. So this gives us x squared, 1x squared. This little guy here is minus 2x. This is now 1. Of course, there's the equals. And 12 divided by 3 is 4. So one thing to notice here is, we remember how we like to isolate our number values to one side of the equal sign. It's not here done already. So let's go ahead and do that. So one thing to notice here is we remember how we like to isolate our number values to one side of the equal sign. It's not here done already. So let's go ahead and do that. So -1 on both sides. That gives us a value of 0 here. Some of you call that a 0 pair. And we've got x squared minus 2x. That's zeroed out. And then 4 minus 1 is 3. So now we're ready to start thinking about the tiles. Okay, so if we just kind of imagine this, we know we're going to be splitting those negative 2x's into 2 equal parts, right? And that each side of the square is going to have half of them. So if you're already thinking through, that means -1 on each side. So if that's the case, yay. Okay, we're not done yet. X minus 2x equals 3. Now to complete this square here, what do we need to add to that side? Well, to verify that, we've got x minus 1 and the length of x minus 1. -1 times -1 makes this a +1. Just right. And of course, if we add 1 to that side, what do we have to do to the other? Of course, we're adding 1 to that side as well. So algebraically, we want to make sure we write that as well. So I'm going to put a +1 here. Tell you what, let's change color so we know what we did. +1. Oh, running out of room. +1. So here's the thing here. This looks kind of messy. You're like, what are we going to do with that? But really, this is a perfect square. That +1 makes it the perfect square. So we can rewrite that as x minus 1 squared. That feels so good to go from all of that down to just this. Of course, bring down the equals, and 3 plus 1 is 4. We're almost done. Pause this, take a second to go ahead and take the square root of both sides, and then turn it back on, and we'll see what answer you got. All right, did you get for your answers x equals 3 or x equals -1? Sometimes you'll see that written as a set, like 3, -1, or -1, 3. But these are the values that make this equation true. There are solutions. Now we could go to the calculator, and if we wanted to check this on the calculator, which of course you want to do, you would go back to the very original equation, 3x squared minus 6x plus 3 equals 12. And let's verify that. Let's go to our table. Oh, I've got all the numbers in there left from the last problem where we had the square root. Remember that? Okay, so I'm going to go back to my second table set and just tell it to start at -1. So when we have a value of -1 for x, the left-hand side has the same value as the right-hand side, so they are equal. So -1 is the correct answer. Let's check out 3. Aha, yay. 3 is also correct because the left-hand side and the right-hand side are equal. Can you see that okay? Of course, you probably have your calculator in front of you as well. All right, so we're good. One last problem of the day, and we're going to try this one without bringing out the tiles. I think we're ready for that. Let's give it a try. If I can find the problem that I wanted us to work. That's the thing. That's pretty funny. And here is our third problem. So let's take a few things to notice. we've got a 2 in front of our x squared, so let's take care of that by either factoring it out or dividing it out. I'm going to go ahead and divide it out by each term. And I know they're terms because they're separated by an operation or an equal sign. This gives us 1x squared, which is a good thing. And 12 divided by 2, that's 6x. Now, because I know that I need to complete the square, I want to leave a little space there. And 14 divided by 2 is 7. And because I have to add something to one side, I'm going to leave a little space to do the same thing on the other side. Because I usually end up without any space. So let's leave some space there. Now, luckily for us, the number term is already isolated. So we didn't have to do any transforming of that equation. So that's one less step we have to do, which is always good. All right, so I told you we weren't going to pull out the tiles for this one, so let's see what we can do. So we've got x squared plus 6x plus something to complete that square. And if we do it correctly, we're going to end up with something squared, right? So remember how we always take those x tiles and split them in half? We put half on one side and half on the other. That gives us a dimension for that square of 3, x plus 3 on one side and x plus 3 on the other. So that's the dimension of the square. So we took that, split it in half, split it in half, and have a side that's x plus 3. But remember those units. I'm going to kind of sketch this. I know I said no tiles, but we can at least sketch it. Remember those units that come down here? To figure that out, we need to say, 3 times 3 gives us 9. So I know we have to add 9 to complete that square. And if we add 9 here, we know we have to add 9 to the other side of the equal sign. Right? So this whole thing is a perfect square now because I took half of the 6x, and that's what the side dimension is, 3. And then I squared that 3 because 3 times 3 is 9, and that's what we added. Those are the units that go in that little corner when we actually use the tiles. Feel free to draw this little picture like I did to help you think through it. So 7 plus 9 is 16. Ooh, I like that. It's a perfect square. That makes it a lot easier. Take a second, pause the video, and figure out what your values for x are. And then we'll check, see how you did. And hopefully you got 2 answers, a value of 1 for x and a value of -7. And of course, you would definitely want to check it on the calculator, because every once in a while you can make a little bitty mistake along the way, and you want to make sure you catch it before you turn in your paper for a grade or something. So let's recap. To find out how to complete the square, divide this in 2, so we can put half on each side. So that's where that 3 came from. And 3 squared gave us the 9. So that 9 goes to both sides. And ta-da! We've got our answers. Have fun completing the square.